Great. So we'll have a pretty intimate workshop today.
Yeah. Yeah.
So yeah, I think you can just jump right in, Case.
Okay, cool.
Yeah.
Thanks, Hitomi. All right. So today we're going to talk about Kubernetes informers and what their role is in cloud native and Kubernetes in general, because they're literally all over the place. It's built into the Go Kubernetes client and Go Kubernetes. So you get these things natively, like they're dynamic and they're shared informers. And they're actually relatively simple. So, but to build a good informer is not that easy, or likewise, to build a good operator is not quite as easy. But we're going to go ahead and talk about that today. And we're going to go through a practical session, hit like 5 slides, and then go back to another project that has an informer. But first, yeah, let's talk about the Kubernetes watch, because this is how the Kubernetes informer does its work. So what we do in Kubernetes when we're building an informer basically tells us to inform us about changes to a given resource. So those changes can be modifications, creations, deletions. To put it quite simply, imagine you are going to build an operator. And what this operator is going to do is it's going to control a web application. And your web application has a deployment, a service, maybe a service account, and it's got like some kind of a stateful set that's a database. And you want your engineers to be able to configure this database and for it to be the exact same every time. So you want to eliminate the hard stuff. Like you don't want to have to deal with the configurations of the database, the init containers and all that. That would have to go and kind of like pre-program your database. So you'd build basically an operator for that, and you'd abstract away like the deployments, the services, the service accounts, the cluster roles, the role bindings, whatever you need to actually deploy your service. And you would create a new CRD called like a web application. And web application might have like replicas. Since it's a web app, it might have like your theme, your color theme. It might have like a language, whether it's like English, Spanish, German, or some other language. But you want to be able to change that on the fly. And you only want to adjust one CR, one custom resource, and not like 50 other things that are involved with this custom resource. So we're trying to eliminate human error. We are trying to eliminate the proverbial fat finger. Oops, I did this wrong. Now I'm going down for a little bit before I figure it out. So we're just trying to make things the exact same every time. Really quick idea. Imagine you have road signs, our regular like metal road signs that we have on the road over hundreds of miles. So all of a sudden the roads change. You have to change the language on the road signs. Something has to change, right? So now without an operator, you're going to go to every road sign. You're going to print a new road sign. You're going to have to send people out there to unscrew the road signs and put the new road sign on for hundreds of miles, right? So thousands of road signs. Now imagine the road signs were digital, and you could just write a single command and change all the road signs as fast as you want, as many times as you want, immediately. This is what an operator does from a very high level. And operators are powered by Kubernetes informers, and Kubernetes informers are powered by Kubernetes Watch. And so let's get into it. Like first, let's talk about how do we talk to Kubernetes through programming languages, not through kubectl. So we basically construct a URL and we point it to the kube API server and we send it requests. So the URL construction is the most important thing. It's actually pretty simple. You have your APIs, group, oops, let me go back. Group, version, namespaces if you want. You don't have to include namespaces. But here is like, if I want to get namespaces, if I want to get pods across all namespaces, I want to get pods in my namespace, all deployments, given deployment, you can be very specific with their API. It's really nice. So we're going to go ahead and start. We're going to go ahead and proxy Kubernetes API server to localhost 8001. So we're just going to do like kubectl proxy. And so now we can actually hit kube API server through its API without credentials, without using our kube config, because it's just hanging out at port 8001. First thing we're going to do, we got a fresh cluster. We have no pods. We got the basic namespaces. We're going to create a pod. All right, we've created a pod now. So first thing we're going to do, we're going to send a GET request to the Kube API server through API v1s. Pods are always v1. There's no group. And we are going to say, give me the names of all the pods. And this is the equivalent of saying, give me the pods across all namespaces, because I haven't given a namespace here. So it's going to give me all the pods, and I'm only getting the names of the pods. So if we do this, we're going to get all the pods. We just created this pod named N. And if we get pods here, we have the same list of pods. And we get the same pods, right? And this is the basic stuff. This is actually a workshop that I give people on my team when we're actually building the Informer. So next, let's get the pods from just the default namespace. API v1 namespace is default, looking for pods again. And we get the N. And we get N as well. And if we want to be like verbose, right, we're using JQ here, but we can just say like, you know, just give me the whole pod spec if we want. It's going to give you the whole pod. Now, if we want to be very specific, we can get like a given pod. And now this is namespace's default pods, and this is the name. So we're looking for the pod that's named N. And we're actually JQing for the name and the resource version. This resource version is going to come up in the end. Really important, the resource version, when you're building an Informer, because the resource version is the state of a Kubernetes object at a given time. All right, now let's get into the query parameters. Like as if you were building the Informer yourself, you can say, I want to watch, right? I want to watch this thing. So I want you to send me all the deltas, every event, right? I'm watching this web app resource because I just want to deploy a web app resource, custom resource, an instance of a CRD. And when this resource is deployed, I want to read the spec and actually deploy my databases, deploy my services, make configurations. The resource version is the state. It says pod given state at a time, but it's any Kubernetes object at a given time. They all increment up, and it's not linear necessarily. It's like across all of that CD. The resource versions are always incrementing up. Allow watch bookmarks. So I don't know how useful this is. We used to have allow watch bookmarks in the Kubernetes Fluent client. We removed them. It's like you can get a bookmark event, and it basically says, hey, there's been no changes on this Kubernetes resource since we last sent you a change. So they send you, Kube API server sends you bookmark to say like, hey, everything's all the same. So it doesn't really help you that much. It just tells you like, hey, we're still watching here. We can be very specific with what we watch or what we get with label selectors and field selectors, and we'll look into that. So now we're gonna actually get into the watch. So we're using another programming language other than Shell, which we're using right now. We would construct this URL, and we'd call straight like kubernetes.default.svc.cluster.local. But since we're proxying out, we're going to watch all pods, and we're just going to get the name, the type of event, because watch comes out with types of events. So like added, modified, deleted, and we're going to get the resource versions of all those. So here on the left pane, you know, we can see N was added, core DNS was added, Trafic was added, load balancer stuff was added. So we're watching, you know, something complicated, right? We're watching a CR most likely for Kubernetes operator. We're going to go ahead and label the pod N with color red. And let's watch for the event that comes up. And we get a modified event. And you know what? Let's label it again, because let's check out the resource version. So N was modified. We have it's sending us back the whole resource, but we're just using the JQ to get the specifics here, just to kind of learn a little easier. Let's just make it easy and do that again. I said colors red this time because I didn't want to overwrite. And now we get another modification. We get the resource versions incrementing up. Keep that resource version in your mind, right? Because we're going to be using that when we build the informer. But another modified event. Oops, O-N. Let's delete that pod really quick. We get the deleted events. So these are the events that you can get: created, modified, added. All right, so now let's be specific. Why would you be specific when you're building a Kubernetes informer or like an operator framework, or just you're straight up building a Kubernetes controller? To reserve network bandwidth, to preserve network bandwidth, to make sure you're not getting wasteful events and having to do all these filters afterwards. So now we're going to look for API v1 pods. We're watching them, but we're looking for pods with metadata.name equals n. So let's try this watch now. All right, so we're watching for pods with name n. Let's go ahead and overwrite it. Color blue. Overwrite. We modified it again, and the resource version has of course incremented up. All right, so keep in mind, we're just watching. We're not using a namespace right now. We're just watching for, with the field selector, metadata.name is n. So we're going to go ahead and run n and kubepublic this time. Show you the importance of using field selectors and kind of isolating what exactly you want, because this can be wrong in your application. It could cause catastrophe. So Nginx. So we're running n, really the same thing. We're going to get an event here, but it's in a different namespace in kubepublic. And check it out. We have an added and we have modified, right? So that's confusing, right? If I was expecting n in my default namespace and now I'm doing some kind of operations, looking for some deployment, well, that would be bad, right? Because it's not really the same, completely different. So yeah, that's a problem. So what we're going to do is now we are going to use our field selector even more. We're looking for a pod with the name of n in the kubepublic namespace. All right, so we have our first event from n. Now we're going to label that pod. Oh, yeah, let me label it. N equals red. N kubepublic. We got our modified event. And now, what if we didn't modify the pod n in the default namespace? Now we don't get that network traffic. So we're preserving the network. We're preserving Kube API server, which is like, you don't want to overwhelm it. And there are limits to Kube API server, which are tweakable. But yep, there are limits. So now what else can we do through like this controller pattern? Well, now let's get the logs from n. So we're API v1 namespace is default. The pod is n, and now we're going to get the log from it. Should be an Nginx log, and we get the Nginx log. And now another thing we can do, which is helpful when you're building operators or controllers, because you don't want to overwhelm your nodes. You don't want to overwhelm your resources. So sometimes it's nice to like kind of probe every now and then to check like, what are our metrics looking like on given nodes? Oops. So I'm basically, there's a simpler way to do this, but I'm going to do it the simpler way. Let's say we get the nodes here. So it's K3S, K3D, K3S default server 0. That's its control plane. All I really need to do is this. Let's do that again. Add in the server name. And then just JQ that. Did I do something wrong? I'll just copy and paste it as is. All right. And now we have node metrics, right? We have CPU, memory. So you can do a lot of things from this. And now let's kind of tie this together. I'm going to do another share. So Kubernetes informers from scratch, just the important parts. So what is an informer actually, right? An informer is a way to react to Kubernetes events that is resistant to failures by the way of eventual consistency, which is crazy, right? Because the watch API is not guaranteed, not at all. It tells you straight up that it might miss events sometimes. And that's very real. It depends on how overloaded your cluster is. But Kubernetes watch events can be missed at times, no matter what you're using, even Kubernetes client Go. But some examples of informers are Operator SDK has informers. Go Kubernetes client has the Kubernetes shared informers, which are actually used in Operator SDK. Kyverno has informers. Prometheus Operator has informers. It's almost like every controller has an informer. And what can you do with an informer? So I want to watch a web app CR. I can read the CR and know which theme to deploy the front end with, what language, which database to back my application. And I want to automate it every time. So I don't want to have to deploy these 9 or 10 resources across several availability zones and make them fall on the right nodes. I just want to watch this web app CR and program my operator to do all this stuff for me. So I want to think really, really hard one time and go through a lot of work. And then for everyone else, I want this to be extremely simple. So an informer literally does just 3 things. One, you start a watch, just like we just watched with the URL. You start a watch for a given resource. We were watching like pods, but once you register a CRD in the cluster, you can watch anything. It'll be registered. So it can be a web app, it can be anything. The second thing you do is once you get an event back from the Kube API server, you store that event in a cache by the resource version. And so your cache should be more like a map string interface, right? It should be a cache for each object. So you have a cache, you'll have the latest object by a resource version. And then on an interval, you're doing a loop, right? And there's something called a cache warm-up period. I don't want to get too much in the weeds, but if you're using the Kubernetes dynamic informers with Go Kubernetes client, Kubernetes SDK, you're going to need to be very careful about your cache warm-up period. But yeah, you're always going to build a cache, and your cache has the latest of everything that you've gotten, everything you've received, so you know what you processed. And now you have this relist interval. So your interval can be whatever you want, but every 5 minutes, I'm going to do a get request. So if we were looking at the URLs, if we want to watch something, we say watch equals true. If we want to just do a get, you're going to do a get, and it's going to bring back all the objects with a given resource version. So what you do then is once you receive a list of all the objects, you compare the resource version from the get list, the one that just happened, with what's in your cache. If the resource version from the gets is higher than the resource version in your cache, that's an indication that you missed this object. So then you will go ahead and process that object, process the event that you missed, and then you'll update the cache. So you're always relisting, comparing the resource versions to those in your cache, and updating your cache and processing the events. And that's how all informers work. Also, really important to note, the cache hydration, like your cache is hydrated, and it depends on how your informer is written. But I think like typically you want to start with the get so you can automatically hydrate your cache, right? Your first get is going to hydrate your cache. Yeah, so when I say update the object, yes, exactly. You're going to store, you don't even need to worry about updating deltas, because if the resource version is higher, you're going to store that latest object in the cache as is. Yeah. If we're worried about like deltas, what we want to do is use service.apply to only like send small chunks to the Kube API server. Like I want to patch this, I want to apply this new deployment, but I only want to change like the labels on it. You can send like the name, the namespace, and just like the deltas on like the labels, and it would do it for you in the back end. But in this case, if you're building the cache, you want to store the latest object. Because yeah, I mean, you could, but it doesn't really matter. But you could use tildes. Yeah, and so why do they do this? Why do they do the watch? Why do they cache everything they get from the watch and then do the relist? So I tell there's no guarantee on watch events. That's it. The more turmoil, the more stress, the more network pressure in a cluster, the more likely it is that something could fail. Resources are finite after all. So I tell Kubernetes to send me all events on pods. Every event on a pod I store in the cache with a unique identifier, and that tells me that I have processed this event. Well, sometimes I miss events, so I call Kube API server to make sure I have all the updates. When I get the update, when I get this latest list of what all the pods look like, what all the resource versions look like, we were using a pod named N. If N has a resource version higher than what I have in my cache, I clearly missed something. Like I missed an event from Kube API server. So then I'm going to store the latest N manifest, the pod that's called N, in my cache, and I'm going to dispatch that event. I'm going to process that event based on this latest resource version, and then I'll store it in my cache. So this is like, someone updated my web app CR that says like, I want to change it from English to Spanish, right? And then my web app server is still like showing English. So then when the relist kicks in, it's going to automatically catch that. So you always want to have an informer. You can't not rely on watch only. No matter how good, like if you're using Rust, Zig, Go, TypeScript, whatever you're using, like you definitely need a cache because there is a lot of churn in clusters. So we're looking for eventual consistency. So this means you will always be consistent. And yes, it does rely on network pressure. And so now to go back, I'm going to kind of finish it up now. And we're going to actually use a real Kubernetes informer now. And this informer was written from scratch. It's written in TypeScript. It does the watch, it does the caching, and it does the relist windows. So if you have this repo, you can just run npm start if you have Node. And what it does is it's watching a kind.pod, right? And then the callback is bringing you back that object and then the face. So whether it was added, modified, created, or updated. And we can see there's two pod ends, like one in public right now, right? So let's label pod n again. And we're just going to say A equals B, get a modified event. Let's delete and get a deleted event. And so, yeah, it's like, this is how informers work. Like it's relatively simple. These things are pertinent, are essential in building your Kubernetes controllers because crazy things happen on the clusters. In fact, when about like last year, no, it was like, yeah, it was a little bit like last year, we were missing events in our Kubernetes informer. And we had to change the underlying network infrastructure. Like we were using this library called Node Fetch actually, and TypeScript. And it was so unstable. And we had our informer like relisting extremely aggressively. And it was literally the informer, like we are on the line for really complex deployments and we can't afford to miss events. And so we had our informer very aggressive. So like at the most, it would have been like 30 seconds of missing an event. Luckily, there's this new fetch library in Node. It's called Undici, and now it's the native fetch. And it like barely ever misses an event. Like we haven't seen a missed event in about 6 months now. But with the informer, it made it less of a bad thing when missed events occurred. But yeah, if you want an informer from scratch, look at Kubernetes Fluent Client, look at Pepper. Pepper's an admission controller and Kubernetes operator framework. But this is what informers are all about: just doing the caching, doing the relists, and processing events. And so, literally, I'm watching pods now. But if this was like a web app resource, I'm like looking at a web app here. Then what I'm going to do here, once I get an event, I'm going to say like if if the phase is equal to like added, I'm going to now like deploy web app deployment service. I'm going to do all this stuff. Likewise, if it were updated, then I'm going to like make small updates. I'm just going to read it, see what I have to change, right? Maybe my deployment says like there's an environment variable that says color equals red, and then I have the theme on my web app CR. I can just change it once because I'm watching the web app CR. Now I can just change the deployment. And so that's actually it. I wanted to keep it short. So let me know if you have any questions.
I have questions.
Sure. Yeah.
Okay, so I used to be technical, not anymore. So, but I work with engineers who work extensively with Kubernetes and cloud native technology. So I understand, no, not to implement, but I understand concepts. So my question is that uh how does the informer handle, if I understood correctly, like a versioning of objects, like especially there, like
Yeah.
rapid changes and updates to resources? I'm just curious to know.
For you.
Mhm.
Yeah. The informer, it's actually etcd that handles the versioning, and then the Kube
Mhm.
API server is basically one of its jobs is to report the state of etcd back. So how it handles versioning is through a resource version update. So if you create 3 instances of web app CRs, it says first time my web app should be black, the next time my web app should be red, and the third time my web app should be blue. It should definitely not go from like black to red. Or black to blue. It should hit all the colors and process those individually, because it wouldn't miss an event. So what your informer is going to do is it's going to store the instances of your web app in the cache by the resource version. And when it gets an update, it's going to process it. Every time it gets an update, it'll process it. But then when the relist occurs, it's always going to say, because it's not necessarily going to process anything on a relist unless the objects it got back have a newer resource version than what's in your cache. So long story short is the resource version that does that in etcd.
Great, great,
Hey,
perfect.
I'm
I
trying to.
understand that, so it's good.
Yeah.
All right,
Cool.
Jose Mar,
Yeah, I'm
you have a
sorry.
question? No, go
Yeah.
ahead.
So I'm trying to formulate this question over here. So bear with me. Recently, I worked with a controller, an operator using the controller runtime. And when I generated the client set and everything else through the automation that you have from the Kubernetes side, it it did a specific differentiation between a informer and listers.
Uh-huh.
I would like to ask you if that is intentional, or do you know? Can you extrapolate why is that differentiation that hard? That you have a lister and you have an informer whenever you generate that code.
I don't know the answer to that.
Okay,
The
I was wondering.
yeah, I'm guessing. If I had to guess, and I could definitely be wrong, but I'm guessing the lister. Well, there would be one reason why I could think of that, and perhaps like like in the shared informers, shared dynamic informers from Kubernetes you get in the Go libraries. You have access to the cache, so you could kind of like extrapolate that and make your own decisions, like by a lister to like list the latest things. But I'm not really sure.
Okay, got it. I was wondering over here regarding the semantics. I thought, or I jumped to the conclusion, and maybe you resound with that maybe informer is just a lister that maintains a cache and
Yeah,
keeps updating. Maybe I need to double check the library. Anyway,
that sounds right. That definitely sounds right. Um, and one little like funny story. Our company has these things called dash days once a quarter. and I ripped out our TypeScript informer. I didn't rip it out. I just changed it for a Go Kubernetes informer, and I sent the events over NATs. So I had a Go informer that was a sidecar to Pepper, and the Go informer was talking straight to Kubernetes, subscribe to the events, and then the Go informer would send the events to a NAT server, and then the Pepper, the TypeScript, was subscribed to the NAT server. So it was like this big triangle, like, just like this. I was sending like, first I sent like 2,000 requests simultaneously to both clusters, then 4,000, then 6,000, then 8,000, and then I realized they're both performing the exact same, because I was the Go Kubernetes informers have been used by thousands of people all the time. They're in Kubernetes themselves, and it's hard to put a ton of pressure on our Kubernetes, on our TypeScript informer, as we are diving more and more into like edge and having way more events in the cluster. And I was so impressed and a little surprised, frankly, with how well the TypeScript informer did with this pattern. Like it didn't miss any events. It was able to handle just as many as the Go informer had, keeping in mind that I didn't go for 6,000 events simultaneously, because we're not going to have that kind of scale. I mean, not immediately at least. But yeah. Cool.
Okay.
Yeah, I have more questions, but those are operator related, not informer. So the
Yeah.
question I have every single time I go into something specific is, what can I do with this knowledge now? Because this is
Mhm.
something so specific for Kubernetes.
Yeah. Like, what do you do with the operator that you're building, or?
No, I'm just asking as a new user over here that joined into the call and
Yeah.
went through the talk, and now it is
Yeah.
wondering, how can I use a Kubernetes informer?
I'd say automate stuff, right? Like automate these tasks where you have to have like legacy knowledge, right? Like, hey, my database always falls over once the metrics, like once it hits a certain metric, once the CPU hits this certain event, like I would use it to automate these things. So every time I deploy Keycloak, I need to adjust this on my deployment so we can get like the realm ID, so my application has it. Automate everything so that it can be completely cloud native, completely configuration as code, so you can just deploy smaller resources instead of deploying tens or hundreds of resources all the time. Abstract those into a higher level resource and let the infrastructure do the work for you.
Awesome, thank you.
Yeah. And so if you have like cool side apps that you make that are cloud native, like abstract the complexities of deployment that are associated with those, or rolling updates or versioning updates into like an operator, and handle it like with a CR. Like, consider Prometheus. The Prometheus configuration is like so big, so ugly, right? But then the Prometheus operator, you have instances of Prometheus, you have service monitors, you have Prometheus rules, and all these do is like they actually tweak that config in real time. So you don't have to like restart things. It's automatically there. So you can make your updates faster. You remove the risk of human error. You can kind of empower your team a lot more. They can do so much more if you can take away all the work that they have to do for them, and like leverage an operator to do that kind of stuff.
All right, let me jump in. So I just had a sudden realization. You can insert the sudden realization meme over here, but so that means that I don't need to embrace a full-fledged operator framework for automating around Kubernetes. I just need to write an informer, as you
Yep.
show here. Is just HTTP um, HTTP client that keep listening and filtering, and you can automate.
That's exactly right. Yeah, you definitely don't need all of that baggage, all of that overhead. You can easily do it yourself. You could do it in shell. Like you can do it however you need to do it. And then you can make your informer more aggressive or less aggressive based on if you think you're missing events, right? Like if you find that you're never missing events, then the cache and the relist window might not even be that important. Like if it suits your use case, it's good to have it as backup, right? But it's like certainly not, you can just do the watch and you can automate anything that you want.
That's super cool. Thank you.
Yeah, no problem.
Any questions, Fabricio?
Actually, I don't know if my microphone is working, so I was listening to everything. I hope that you hear me.
Yeah.
Hello, everyone, guys.
Hey. Hello.
I heard everything about the appliance and so on. Generally, my approach is on controllers and operator because they are the ending point probably with what we are talking today. I was curious to hear from you, Casey, about NATs. So you mentioned NATs a lot. I'm using NATs as a replacement of Kafka, and so we are talking about something that is really high performance. Our use case is for distributed systems. So we use leaf nodes, a configuration that is oriented to distribute the message and reach also the multi-clustering appliance for a message that is generally included in whatever action is translated to an operation on top of our systems. I was curious to know about your current usage of NATs, if you have been using jet streams or normal queues, if you have been using gateways, superclusters, leaf nodes, or just the normal approach that you just do the jet stream between two NAS nodes. How was your experience on that?
Yeah, it was just a POC. It wasn't running multi-cluster, single in a cluster. I had one NAT server, and the NAT server only had one subscriber. But I found it fantastic. I wasn't using Jetstream, just the regular NATS C or C++ server. But I found it, like, first of all, it only takes 30 megabytes to run that. Like, it's tiny. It's so fast. I thought it was a pleasure to work with. And I would have probably needed to use gateways had it been a more complex setup like the one that you're describing. But in the setup I had, it was really great. Very, very nice. Very easy too.
Great, thank you. And
no
what about the idea of observers in generally relating to our case of watches and operators when you are targeting multi-clustering? You mentioned that it was not on multi-clustering, but what would be a suggestion, in example, to write a controller that is communicating via Istio or some kind of service mesh instead of using the typical Calico Cilium multi-clustering approach that is quite based on the network? So if you think about APIs of Kubernetes, so you talk from one cluster to another just using the base controller of Kubernetes and the API. Do you have some experience on that or some suggestion?
Yeah, I have two interesting thoughts on that because the product that I work on is an admission controller, and it has like the Kubernetes watch and Informer built in, and we could easily run this controller outside of Kubernetes, right? You're validating or mutating admission webhooks do not have to run inside of Kubernetes. They can run outside. There's like a pure URL you can send them to. And then in response, if you had the kube config for multi-cluster and you had the credentials, you could make reactions in any cluster that you want, right? And that would be like a control cluster. The one cluster would be a control cluster. This would be a good way to do like blue-green deployments, things like that, like continuous deployments. But so an admission controller could do that. But at my last job at Red Hat, we were working with something called Submariner or Submariner. I actually don't know how to pronounce it. But it sends it
I think
to
it's Submariner.
Yeah. It sends it to a cluster set, and a cluster set's like a multi-cluster service. And you connect these, you basically subscribe across to this service across all clusters. And Submariner for multi-cluster worked very, very well because we were using it to connect instances of Cockroach databases. We would spin them up on OpenShift, and we'd spin one up in GCP, one in AWS, one in Azure. And we'd have we were using something called ACM as well. It's like Advanced Cluster Manager. And it's basically like hub and spoke clusters. So you'd have like a management cluster and you'd have these leaf nodes, but they're fully clusters. And we'd be sending those events through that cluster set service, and they would all receive the events. I love working with Submariner. It's really nice and it's lightweight.
I take the suggestion to retake Submariner because I was looking at it for some kind of workload management for the appliance of a KubeVirt setup. So everything related to virtualization, we are practically moving a lot of customers to bare metal back because it seems it's the current trendy approach for that. And I was using that not on top of OpenShift. I've been trying that also on OKD, so it's very similar. It's probably like OpenShift, but on RKE2 for my case. And that part related to NATS, the actions, the multi-clustering, and this idea about the informers. So using a simple, very lightweight way of informing one cluster to the other parts with watch, inform, and the activities that we were talking about is really interesting because it's lightweight using the Kubernetes API. So you don't have to set up a VPN or something like that. You just have a public endpoint that can be managed by Istio. So thank you for the ideas. I have no more questions.
It's a great question. Yeah, great question.
Thank you.
Cool. Yeah, that sounds very interesting too, what you're doing. Cool.
We enjoy Kubernetes.
Cool. That's great. Awesome. Well, thank you all so much. Yeah, been a pleasure.
Great. Well, Samar, you have any more questions?
A ton, but it is off topic. So thank you. Thank you for all the knowledge for today.
Yeah, anytime. Yeah. Let's chat on Slack if you want to. Yeah.
All right. Great. So I think we can wrap up the meeting then. So we have the YouTube. If you wanna watch the the session over, we have a YouTube channel and then we publish it so you can watch it again. And then I just published the GitHub link as well. And then so we'll be able to test it out and see. So I think we can wrap up.
Sounds good. Bye, everyone.
Thank you very much.
Thank you.
Bye.
Bye.
Thank you.
Bye.